Okay, so welcome everyone again to today's webinar. This webinar is hosted by the Northern Rockies Fire Science Network, which is part of the Joint Fire Science Program's Fire Science Exchange Network, and also co-hosted by the Rocky Mountain Research Station Missoula Fire Science Lab. And it's being put on in collaboration with several of the other um, regional fire science exchanges across the country. So I'll drop in the chat here a couple of links to our exchange and then to the broader JFSP Fire Science Exchange Network. So if you're not in the Northern Rockies region, you can go to the JFSP page and find your region. We're really excited today to be hearing from the co-development leads of Behave7. So without further ado, I will let you guys take it away.
Good morning, everybody. I'm Faith Ann Heinch, and I kind of invented this thing that we're doing right now. But Lowen has joined me in this, and I believe she's going to introduce herself later when she does her demo. Um, I am I've been at the Fire Lab since about 2009 in various capacities, but the entire time, one of my jobs has been Behave. And one of my dreams for the last 10 years, at least, has been to create a new Behave just to make it easier for the users. And so that is why I am happy today to be presenting the webinar to you guys. My background, I've got a PhD in environmental physics from Texas A&M University. I came out to the university here and worked for a while with satellite data. And then I came to the fire lab where I've done mostly fire behavior model development and maintenance training and help desk support. So without any further ado, I'm going to get started on the presentation. The plan is we'll have a brief presentation, and then we'll look at the demo, 3 demos that we have set out, and then along the way, we'll ask any questions that we need to. Darcy and Signe, can you see my presentation?
Yes.
Okay, perfect. So what we're planning on doing today is first really outlining the differences between Behave 6 and Behave 7. Behave 7 is completely new. So we're not going to go, well, this is different from that, and this works this way and that. We're just going to stay, look, we know what Behave 6 looked like. Here's Behave 7, and here's some big things. We're also going to talk about some enhancements that we're going to be including in the next few releases over about the next year or so. These are the ones that we have at the highest priority. It doesn't mean that's all that's going to happen, and I can't promise a date that it's going to happen. The presentation and the demo will be most useful today for fire analysts and then those on the S390 and S490 cadres. So hopefully all of you will find it useful. And again, if you have any questions, just let us know. So I just wanted to remind you guys of Behave 6. It was first released in 2002, so it's got quite a bit of age on it. Fun fact, my dad actually alpha tested Behave 6. So that's it. But we have our worksheet. We have all of our module selections, and then you have your tabular outputs and your graphs. And I will never forget the way that you navigate between the pages with the blue arrows, because I will not be missing that. But for 2002, or as I call it, cutting edge 1998 technology, it's worked really well for a long time. But when we were looking at Behave 7, we had about a year actually where we were looking at this with a UI UX expert from the Spatial Informatics Group, who is our co-developer on all of this with the Forest Service. And she sat down and made us really think about what we wanted to do to help the users. And so we knew from the get-go we wanted to do the outputs first, because trying to teach students, we found out they would fill out all the inputs and then go create the outputs they wanted and then find out the inputs were actually different. So you don't have a choice now. You put in the outputs first, and then we retained the ability. We only show the inputs that are required to calculate the outputs that you choose. We definitely simplified a lot of choices for analysis, at least in the guided workflow, because we wanted to make sure that people didn't get lost in the over 200 variables that are in Behave. We wanted to just show them the things they're really interested in. And we wanted to prevent users from making common errors. For example, there's certain modules like crown really needs to be tied to surface, and your inputs need to be for both of those because that's the way crown was developed. So to prevent people from making errors like that, at least in the guided workflow, you don't have a choice, and I'll show you that. When we're creating it, Behave7 was completely rewritten. Not only was the interface rewritten, but we took the code and we separated the interface from the code itself. And we decided we broke the code down into basic code blocks, which hadn't been done. And I say we, like Lowen and I did it, but we did not. Mark Finney let us use one of his computer programmers, Bill Chatham, who's no longer with the Forest Service. He left a couple years ago. But he took on the challenge of doing this, and it did not break him, so that was good. But we also wanted consistency between the Fire Lab or between Behave's code and other systems. So in order to do that, we took the surface and crown fire behavior code from FlamMap version 6.2, and we've added that directly into Behave. So when you calculate your surface and crown fire behavior, it should be exactly the same as it is in FlamMap because it's using the same code. The probability of mortality, FOFM, we couldn't update Behave after 2018 for a variety of reasons. And so FOFM had newer code. We took the code wholesale into Behave for the probability of mortality. And then finally for Contain, the Wildland Fire Investment Planning System, Mark Finney's group had developed a new Contain model or updates to the Contain model for WIFIPs, and we took that code as well, just to make sure we had the best science that's available right now and that we match as much as possible. The other thing we thought about as we were doing this was rather than giving everybody the same interface from the get-go, we would create workflows, and this would provide the information needed by an audience. So if you're a beginner or an intermediate user, you're not directly going to get dumped into selecting all of the modules and everything like that. We have what's called a guided workflow that will take you step by step through the process. Once you get some experience and are an analyst, you tend to want to go, you know the system, you know how to make it work. We're going to have a standard workflow. That's currently under development, and we hope to have it out in June before the July fire season, but it's still in development, so I can't promise a date on that yet. And then finally, one that I've been wanting to do for a long time is the researchers in the world have been asking for code that can take batch files in it. And so we've got that partially developed in that you can export all of your data into a CSV file that can be easily used anywhere else. But we don't have the part where you can upload a batch file yet. That's going to be the last workflow that we develop. There could be more in the future, but these are the three that we're looking at now. Some other updates that we've had along the way. In the past, you could enter multiple values for 2 variables. Now you can enter them for 3. And when we get to the kitchen sink or researcher version, I believe we will have more than that, but we will not be doing any graphing or any tables. We'll just be creating a CSV file that you can download. If you have 3 variables that you use, for example, you want to look at fuel model, 1 hour fuel moisture, and wind speed, for example. It'll produce the graphs and show you all of those, but it will not produce tables because we couldn't figure out a way to do that in a streamlined manner and make it look good without taking up pages and pages of screen. All the data, however, can be exported in a CSV file for you to use however you want to do that. Files can now be stored anywhere on your computer. You no longer have to remember to go to C/BehavePlus/Behave6/default data folder /run file or export or whatever. They can be stored anywhere. And Behave itself can be put anywhere on your computer, and I'll talk about that a bit more in a minute. And then finally, we've added a notes section so that when you're doing a run, you can add notes to document what you're doing. And that will help as you move forward and someone else reads your run or you come back a year later, you can remember why you chose what you chose. So we encourage the use of the notes, and it should be a lot easier. It's on every page as opposed to being just at the bottom of the main worksheet. The last one, and the one that we are probably the most excited about, ironically, is interpreting surface and crown fire behavior. In the original Behave, we looked at crown fire type, and the first thing we did was we got rid of conditional crown. Conditional crown is just says that if an active crown fire burns into the area, it will maintain active crown fire. That crown fire is independent from the ground, and therefore we really can't model it. We can simply say that's what you have. So rather than that, if it burns through there, it's actually a surface fire. So we've changed it to surface fire, and that's how Flam Map works on it. The other thing we do is we have the surface rate of spread. And so in the old system, you had to look and see which ones had surface fire and figure out what outputs were related to that. And if you had crowning fire, it was fairly easy. You just went to the active crown fire rate of spread. So those two were fairly easy. With surface, you go to the surface spread. With crown, you go to the crown spread, but all of them were produced for all of the variables at one time. And then we got to the fun part. Depending on whether you use the Rothermel version of crown fire or Scott and Reinhardt, you had two different answers. In Rothermel, you assumed that you had a surface rate of spread and an active crown fire flame length for torching fire. And so you had to remember to go to the two different tables to get that. And in Scott and Reinhardt, you were looking at the passive crown fire rate of spread and passive crown fire flame length. This was massively confusing for all of us. And so in the new system, we don't do that anymore. We've actually got things written so that if you have a surface fire, it's going to give you the outputs for rate of spread and flame length. Point those out. The rate of spread here and flame length, it will give you automatically the surface fire, and then the graphs are going to graph the surface fire as well. If you go to torching, it's actually going to give you the torching rate of spread and the torching flame length, regardless of the model that you choose. If you choose Finney, in this case, it's not Rothermel anymore, it's Finney. It's a modification of Rothermel. It's going to pick the correct units, and the same for Scott and Reinhardt. And then finally, if you go into crowning, it's going to also include that in the graphs and give you the correct models. So you no longer have to guess at what you're looking at. And hopefully the students in 490 will be able to, it'll make sense to them a lot more than the previous version ever could. In version 7, we've got it set up. It runs on a browser window. So it's Java based. The code itself is C++ code. It's available on GitHub, but the system itself runs on Java. And what it does is it accesses the code in your the calculation code in your browser window to make the calculations. It does not contact the internet in any way, and it's called the local host, and it will just do the calculations from there. With that, there is no installation of the software. All you do is you take the jar file that we have, you put it somewhere on your computer, and you should be able to run it with Java. There's a couple of issues that we're having right now running it with the latest version of Java, because of course that came out right after we released this. The timing always happens that way. So we're working on that bug, and we've got a couple of suggestions if you do run into that of how to fix that. It works fine on Lowen's computer, and I can't make it work on mine. The next thing is if you ever want to just start over, you're like, I'm done. I need to start over. If you click on the logo, it brings you back to this screen and clears out everything that you've done. The modules here tell you we've reduced everything down to 4 modules. So in Behave 6, you had surface, crown, let me see, scorch, mortality. Oh, you had size, probability of ignition, and I thought there was one more, but there's 6 right there. We've reduced it down to 4. We've included the probability of ignition and spotting. That was the one. Size, surface spotting, and probability of ignition are in surface. In crown, we've added size, spotting from torching trees and active crown fire, and probability of ignition in that one as well. And then in contain, we haven't made changes there, and mortality also includes the scorch. So kind of reduced it down to broad categories for ourselves. We still maintained all of the tools from the old system. The calculation of 1 hour fuel moisture and calculating slope, all of those things. They're now called calculators, but they are in there. And then in the settings, you can look at changing your variables, the number of decimal places you want, whether you want to do English or metric units. You can also change it inside the program, but if you want to do a wholesale change, that'll be in the settings. Currently, we only have the guided workflow available, but you can also open or import an existing file. With all of the things that happened in between Behave 6 and 7, we could not figure out a way to import Behave 6 files. So I apologize deeply and for that, but you're going to have to create the files in 7. Fish and Wildlife Service has not been approved to use Java. I can say that if you can use Amazon Corretto, it's the same thing, or any OpenJDK, it should work the same. So you don't have to use Java itself, but you can use one of the others. And I will demonstrate opening and importing an existing file to show you guys how that works as well. The help, we still maintain the help. It does change dynamically as you move through the system. One of the things that we wanted to make sure we could do is if we run out of space, we want it to be able to maximize the working area. So if you're in a small window, you want it to be able to maximize the working area. So you can take the working area, it'll take over the whole window. Or you can just close the help, or you can just close the modules. And finally, we've got the home button, which will bring you back home to the main page. The save button allows you to save your run. And the print here really allows you to print to either a PDF or a printer, but it's going to be in a PDF-like format. So it's going to be formatted for you and hopefully provide things in an easier to use format. Okay, let me get over here again. When we wanted to, at least in the guided workflow, this is not every workflow, this is only the guided workflow, we wanted to save the students from a lot of hassle, so we broke it out. You can do surface fire behavior only. You can combine surface and crown fire together. You can calculate surface and mortality together. You can look at containment by calculating both surface fire behavior and containment. Or coming soon, it doesn't work yet, you can look at the mortality only, and this is affectionately called mortality for weirdos. It's going to have all the mortality equations of FOFM in it and a lot of the outputs that are needed as well. So that one's not developed yet, but it's coming. The 3 we're going to focus on today are surface only, surface and crown, and surface and contain, or as we call them, shorthand, surface, crown, and contain. Showing you the outputs and what they look like first. The first thing I want to show you is the notes. It will always tell you what module you're in. So in this case, I'm looking at surface. The color will also give you an idea. The color in surface is green. The show notes button is showing. If you click on that, it will open the notes window and allow you to edit. The modules on the left-hand side show you which modules you're actually using right now. Again, we're only using surface. Two tabs on the right-hand side show you the difference between the outputs and the inputs. And the one that is the dark blue is the one that's currently active. But you can click back and forth between them to go back and forth. If you want to add an output or remove an output, you can go back and forth. The outputs themselves, we have simplified those as much as possible to fire behavior, fire size, spotting distance, and wind and fuel. And that's a calculation of the mid-flame wind speed and then fuel loads within the model. For spotting from the surface model, you've got spotting from a wind-driven surface fire and spotting from burning piles. If you choose spotting from burning piles, you do not need to, you cannot select any fire behavior to go with it because there's really no model that goes with that. But spotting from a wind-driven surface fire, that spotting model in particular can only run in grasslands. It can't be run in heavy shrub or anything like that. So we've limited the fuel models for that to the ones that can be used for that when you go to select your inputs. But just to let you know, wind-driven spotting from wind-driven surface fire is actually only for grass. It's not all of them. And again, the help system will move as you go down the list. The back and next buttons allow you to navigate between the different areas of the screen. So now we've got the inputs here. Oops. We've got the fuel model. You'll have fuel moisture, wind and slope, and then the elements needed for size. If I had selected one of the spotting models, a tab for spot would show up. But since I didn't, that is now hidden. In the fuel models, we'll go into it a little bit later. We've added a few more fuel models for us to try, given a few other things that are going on. And in surface and crown, we have the wind and fuel. I believe we're going to delete that, but surface is going to be green, crown is going to show up as orange. And we have fire behavior, fire type, size, and spot as possible outputs. And if you go into the inputs, you'll be able to select the fuel model, fuel moisture, wind and slope, but most importantly, the crown fire method that you want to use. Again, Rothermill is replaced with Finney, which is a modification of the existing Rothermill, and then we've got the Scott and Reinhardt model in there as well. And then finally, we've got surface and contain on the left-hand side. You'll notice that both the surface and contain modules are there. Surface is going to be green, and wind and fuel. So you can see that fire behavior and wind and fuel are both going to be surface, and then fire itself is going to be contain. Again, you've got the inputs and outputs going back and forth. And once you get into the inputs, you can definitely tell that the suppression is going to be in there. And I've decided to call it light red because some people don't like the word pink in fire. So it's a very pale red. But that allows you to put in all of the information that you needed before in your system. One of the things that we've done is instead of the way Behave6 did it, we were able to select that you could add a resource, just like we do in a lot of other systems. You can just click on add a resource, inputs similar to the ones above will show, and you can keep adding resources until you're done listing all of the resources that you have. The other thing that we can do, though, is if you don't want to list any resources and you just want to calculate what is the minimum production rate I need for containment. And in this case, Behave is going to look at your contain status and see what production rate it was contained at, and then it's going to give you that number. So these are the minimum numbers that you would need in order to contain this according to the estimates based on the inputs provided. So we've got the fire area at the first resource arrival time. So at the start of containment, we've got the total contained area, the time from report. So that's the minimum time to containment from report. and the fire line produced during that time. In the table, you'll notice that the resource line production rate was about 50. We calculated, and we'll give you the exact calculation for that and allow you to interpolate from there. So the actual production rate was 48 in this case. Um, some of the things we're looking at in the future, we've had issues with Java and Amazon Corretto. It works on some computers, it doesn't on others. So we're developing a package that will simply run everything from within a single jar file. So it will open its own browser, it will open its own Chromium browser window. It will have its own Java package of whatever it needs. I don't know which one they're using, and will work with all of the DOI agencies to make sure that this gets approved. And we'll be adding a standard workflow, which is the one that looks more like the old Behave. We are going to add a calculator for the safe separation distance and safety zone calculation that is used, that Dan Jimenez has developed along with Brett Butler. We're going to add custom fuel models and custom moisture scenarios. Those are coming. Not everything from Behave 6 has been implemented yet, but we didn't want to wait. We wanted to get it out. So those are coming. The species-specific fuel models, chaparral, pimento gallberry, western aspen, those will be coming. And then we have a new wind adjustment factor calculation developed by Massman and Forthofer, and Jason Forthofer is working on that now in order to get that finalized for use in the program. The model itself has been published, but how we simplify it to use in Behave has not yet been decided. We will do a demo, but before we do that, I want to give some thank yous out to all the fire analysts and burn bosses who helped us develop the vision and tested Behave7 along the way, and those of you who will help us with the vision in the future and continue testing. Any feedback that you have along the way, please let us know. We constantly want to improve this. This isn't for us, it's for you. So we want to make it as helpful as possible. I really want to thank Forest Service Research and Development. They've worked hard to make sure that we get this done and have provided the bulk of the funding. At the research station, Lisa Bryant and Larry Wiegand. Lisa has done a lot of the publicity, and Larry Wiegand has been our direct link to the CIO in the Forest Service. At Fire, Fuel, and Smoke, Sarah Brown, program manager, and Thomas DeZamba, the deputy program manager, have been with us from the start of this. And then scientists like Mark Finney, Sharon Hood, Matt Jolly, Natalie Wegenbrenner, Jason Forthofer, been invaluable in helping us get this done. Signe is helping us with all of the publicity related to this and keeping us on our toes, making sure we get everything updated. Hugh's been helping us as we import the Flam Map program software into this, and then Bill Chatham, I mentioned earlier. At the Fire Modeling Institute, Greg Dillon, the director, who's our direct boss, has just been a champion for us all along the way and encouraging us and kind of letting us have our lead a little bit and let us see what we can do and get done legally in a useful program. And then Duncan Lutz provided us with help in enacting both of them into the software, and he's not done yet, so he'll continue to help. In the CIO, we worked with Mike Gallagher, Bruce Boydston, and John Klein to get the initial development of Behave approved. And then once we had the release with Java, the most recent release has already been approved for the Forest Service. John Klein did that right before he retired. So none of these three worked for us, worked for the Forest Service anymore, but all of them worked hard to make sure that this happened and got approved before they left. I really appreciate that from them. And Forest Service Fire and Aviation Management IT Group, or FAMIT, also provided funding for this along the way, and that's been really helpful. And I have to really thank Teddy Lamore for helping keep all of our budgeting for that and the original Behave 6 in place all these years. Spatial Informatics Group is our we have a joint venture agreement with them, so they are our colleagues in this. David Saw is the lead. Teal Dimitri and Thomas DeVera helped us early on in the visioning. I forgot to put Andrea in here, and she was the one with the UI UX, so I need to add her for sure. Jordan Combs and now Shauna Hobbs have been the project managers. RJ Shepard and Kenny Chung, they have been our programmers, and they've done everything that we've asked. Antonio Pedreo was introduced to us by Brett Shields, and he's helped us to interpret the Portuguese fuel models into English so that we can hopefully use those in some of the Mediterranean systems in the US. At the University of Idaho, we've got frames. Diana Olson and Kelly Lutz run our website for us and keep everything on there straight and update it when they see things are out of date, even if we haven't contacted them yet. And then, of course, the Fire Science Exchange networks, especially Northern Rockies with Darcy and Ella. But all of the Science Exchange networks, they've been really supportive over the years, and I want to thank you for that continued support. And now for the demo. Are there any questions before we get started on the demo?
Yeah, so a couple from the chat. Um, there was one, somebody asked, is there a preferred browser to use, or will any browser work just fine?
It's been mainly tested on Chrome, but it does work on Firefox and it does work on Edge, at least the current versions. I did test it on both of those. So, but we by default use Chrome.
Okay. Um, and then I think you already sort of addressed the issues with Java not being approved by some places. So the workaround for that is the Amazon Corretto, correct?
That's correct. Yeah.
Okay.
And a
Um,
lot of places, if they don't have Java approved, they have Corretto approved. So we're able to make
okay.
it work for them.
And then another from the chat, since the UI is a browser and the implementation language is Java, can you run it on a Mac or a Linux system?
Yes, for the first time in the history of Behave, I can answer that question with a resounding yes. You can run it on Windows, Mac, or Linux systems.
Yay, that's
So
exciting.
that's probably the most exciting thing I can say today. So,
Awesome.
um, the biggest difference between Behave 6 and 7, everything. I think the biggest difference is going to be the interface. But some of the answers will differ as well because we have updated the code to match other systems. So I think hopefully from my perspective, the biggest difference that you'll notice is that it's much easier to create a run and do an analysis and get the answers that you want, and also document what you did during that time. In the end, hopefully, we're still developing the PDF output, so it's not finalized yet, but at the end, hopefully it will give you everything you need to provide um, a full documentation package for the run. And with that, I don't see any questions right now, so I'm going to go ahead and start on my demo. I'm demoing Surface, and then I will take a break and let Luwen take over, and she can correct everything that I've gotten wrong and add everything I've forgotten along the way. So again, the first thing you do in Behave is I'm actually using an online version of the software. It's not actually approved for use in the field. But since I can't access it on my desktop, I'm using this version. We did ensure that Behave7 will not store your data at any point on the browser. So while this version is connected to the internet, nothing is stored. I worked hard to make that happen. Therefore, if you do not save your run before you leave, any work that you did is gone. The next thing is to select a work file. Right now, we have a choice between a guided work file and opening or importing an existing file. I'm going to start with the guided workflow. And I'm going to go to the next. I am responsible for Surface only. So I'm going to look at this one. But before we do that, after we start that, I'm going to do a couple other things in here. So the next thing I'm going to do is you get to choose your fire direction, heading, flanking, and backing, or direction of interest, and then your surface fire rate of spread and flame length. You can either click the next button or you can click on the tabs. In size, I'm going to pick fire perimeter and fire area. For spotting, I can't select burning pile because I've selected some of the fire behavior. If I go back and turn off the fire behavior, let me do that here. Then when I go to spotting, wait, what is that? What did I miss? All right, let me start over. There we go. I think it's got because I have heading selected and I have to uncheck that and I can't. So let me go back in here. I'm gonna have to get that fixed. And now you can select burning pile. And that's because the spread model does not work for burning piles, and most of the pile burning occurs in areas when it's snowing, and snow does not typically carry fire. So we've don't include that in there. So I'll go back and select my outputs real quick for fire behavior and size. And then finally, wind and fuel. If you want to find out if you're using 20-foot wind speed and you want to know what the mid-flame wind speed was, you can select that. So this is mid-flame wind speed as an output. And then if you're doing anything looking at how the dynamic fuel models are working, you can look at the fuel loads in there as well. When you're done adding your outputs, you can either click Next or you can click on the Inputs tab. We're trying to give you as many ways as possible to do things so that you'll find the one that works for you. For the fuel model in the guided workflow, we only allow you to select your fuel model. And this is where I wanted to say we have the 53 fuel models. So we have the 13 from Rothermel and Albini that were published by Anderson. And then we have the 40 that were created by Scott and Bergen. We also have a number of 17 Mediterranean fuel models. These were developed in Portugal. The Portuguese are our second biggest user of Behave, and they've developed their own fuel models for use in Behave, and we wanted to add those for them. But we also want to test. We're pretty sure they're going to be good for use, perhaps in the southeast, but also in Mediterranean systems along the west coast. And then David Weiss had developed the Chaparral and Coastal Sage fuel models. There's 5 of those, and they've always been in Behave, but you had to remember to attach them, and they're part of this as well. So as you scroll down in the list, you'll see the color change once you get to the different fuel models that you've got here. This is all of the fuel models listed, but you can also select by type: grass, grass shrub, timber understory, timber litter, and slash blowdown. I am going to look at timber understory, and I'm going to pick TU5. This helps eliminate the need to go through all of the fuel models at one time because 53 was a lot. 53 plus 17 plus 5 is even more. That's not to say we have to learn them all in the classes, just know that they're there if the 53 don't work. Next, we do fuel moisture. Similar to before, we have a choice of individual size class, dead and live, and dead, live, urban, live, woody categories, and then a moisture scenario. I'm going to pick the individual size class. And let's assume I don't know what the 1 hour fuel moisture is. I can actually go into the calculator and click on 1 hour fuel moisture, and it will open up similar to what it did before. Right now, it's not linked into the software. It works independently, just like it did in Behave6, but eventually we want to be able to add a tab next to 1 hour where we can calculate that using that tool. The other tools we have in there right now are probability of ignition, the calculating slope map measurements tool, and then vapor pressure deficit. Vapor pressure deficit is taught as a drought metric in S390, and you can't, the Weather Service doesn't calculate it and provide it as part of a spot weather forecast or a general forecast. So we allow you to take your air temperature and relative humidity and calculate that from that tool. I'm going to put in my 1 hour fuel moisture. To select it, I'm going to go to my range, and I am going to go from 12 to 4 in a step of -2. And then I'm going to insert the range. And I'm doing it backwards because I want to go from least to highest fire behavior. So that's why I've done that. The 10 hour fuel moisture, I put in an 8. For the 100 hour, I've got a 10%, and the live woody fuel moisture is 100. If you want to know what the fuel moistures are, if you scroll down here, you'll see this table. And you can, when you hover over it, click expand, and the table will come out and show you the full table. It does the same thing for mid-flame wind speed. And we developed this, it's a newer table looking at combining both the Rothermill and Scott and Bergen moistures together, but also separating herbaceous, which is what both original tables were built for, from woody. And we've developed this and then had a number of people around the country take a look at it and make sure that it makes sense to them. So if you've got any feedback, definitely let us know on that. I've got all my inputs, so I'm going to go next. For the wind speed, I am going to go to 20 foot. And my wind speed is going to be 5 to 15 in steps of 1. I'll insert the range. It asks for a wind adjustment factor. Right now we have user input because we will be adding the Massman Forthofer wind adjustment factor soon. So we're anticipating that. If you go down to the table, because you don't remember what they are, we're teaching the students, again, the table will come up. It's the same table that's in both the fire behavior field guide and then also the old Behave. So when I look in there, I find out that my wind adjustment factor is going to be a 0.3. To make things simpler for students, especially when we teach 390, we've always talked about the fact that if your slope is between, if your wind is within 30 degrees of upslope, then you can just assume that it's upslope without making a correction. Otherwise, you've got to figure out what it is. And at least the students here in the Northern Rockies we found have always figured out what that slope is exactly because they didn't remember this. So we've tried to make it a little easier. If they're within 30 degrees from upslope, then we provided that and we have an image that they can see. If you click on the image, it will bring it up. And then if they're more than that, it's not aligned. It will ask you what the wind direction is. The wind direction is always from upslope. We really couldn't find anybody that used wind direction from north, so we always have wind direction from upslope. And the slope that I'm going to input in this case is going to be 20%. So I'll enter that, and then I'll go to size. And my elapsed time on this one is going to be 1.5 hours. At this point, I have to click next. But I want to point out at the top that if I want to quickly go back, this shows me kind of where I am in the process. I did my outputs, I did my inputs. Next up is worksheet review. I can't click on it because I haven't activated it yet. I click next to activate it, and now I can go between these three. Any notes that I produced along the way would show up here. So for example, if I were going to go back to my fuel moisture, show my notes, under fuel moisture, I can add some notes here. If I can type. And I can save that. Then when I go back to the worksheet review, I can see that it's there and it will also show up on the outputs. On this screen, if I missed entering an input, it would turn red and you would not be able to move forward until you fixed it. But since I have all of mine in there, and if I want to change anything along the way, I just hit change selection. It'll take me back to that screen. It's doing a calculation. These are the preliminary results. On this table, it allows you to convert to map units. So if you want to draw on a map like we do in 390 and 490, you can automatically convert to map units, and it's a lot easier than finding it in the old Behave. If you want to do table shading, you can establish that on these. And if it produces tables, it will provide the table shading for that. I'm going to go ahead and say that the flame length, the minimum flame length is 4, the maximum is 8. I'm going to say it's got to be 5 to 6. And we'll show you what that happens. By default, it will display the graph results, but you can turn that off if you want. And then if you want to change your range of any of the things that are being graphed, you can change that here to change the size of the axes on your graph. I'm going to go to next, and this now shows me all of the results. These tabs at the top just take you to the section on this page where you are. So if I scroll down, I've got my notes on the inputs. I have all of my inputs here. And then you go to the tables, and if you can see right now, anything that's X'd out, similar to the old Behave, does not meet my criteria of the flame length being 5 to 6. So if I go to the flame length, all the values that are here are 5 to 6. We decided to use an X, a thin X, because then you can see the number under it, because if it's close enough for you to feel comfortable with, then you can add that to your list. And it will go all the way through to what's acceptable. You can download your results as a CSV file. It's comma delimited. All the variables are in there. All your inputs and your outputs. And then we have the graphs themselves. You can't click and blow the graphs up, but you can save them as in a number of different sizes. You can look at a PNG. You can also open it in a Vega editor, which allows you to do some editing of the graph. Or you can view the compiled editor, which to me means nothing. But you can also just download, save it as a PNG, and put it, I'm going to put it on my desktop as the rate of spread and save it. And then I can open that. And I'll show you what that looks like. It gives you a slightly larger version of the graph that you can then use if you need a quick screenshot of it. We also have flame length, fire area, fire perimeter. Every graph can be output. And if I want to save my run, I'm like, this is a run I want to save, I will click on save. And the screen should come up. All right, hit save. Okay, my screen froze because the internet here is going a bit berserk. If it doesn't work, I'm going to switch it to Luwen and let her take over at the point. Let's see if it'll let me save it now. Okay. Or you can print it. It's going to print as a PDF. And you can save it. You can print directly to a printer. But you got your inputs, your tables. The table shading, we're obviously going to have to work on a little bit because that's not going to work. And graphs still need a little work apparently, or my system is really doesn't have good internet. So that looked perfect yesterday, of course, and today it doesn't. If I want to start over, I can click on the B. That takes me back to the beginning, and I can open or import an existing file. So let me figure out where I saved that file. So I can just go straight there. Here it is. Okay. So I will open or import an existing file, go to next, and you're going to browse to your file. I am going to go to where I stored my files. I'll open up my surface run and open, go to next, and it's going to take me to exactly the run that I did before. If I don't want to make any changes, I can look quickly, see everything, look at the inputs, make sure they're in there. But then I can go to the last tab, click next, and then get to a run relatively quickly. And with that, I'm going to stop sharing and I'm going to let Luwen take over.
Good morning, good afternoon, depending on your location. Luwen Hollingsworth, I'm a fire behavior specialist here at the Missoula Fire Sciences Lab. I've been involved with the Behave revision since the beginning. Just a little bit about my background. I was the lead instructor for 490 here in the Northern Rockies for 7 years. and still am part of the S490 National Steering Committee. And I work in both the spatial and spatial and point system. And I behave a little bit. I behave sometimes. I wanted to answer one question from the Q&A, mostly because I clicked the wrong button. So there was a question on incorporating spotting from shrub models. So there is no spotting model that is specific to shrubs, and that is why you will not find it in Behave. Probably about the best proxy is to use the grassland spotting model and see how it compares based on real life observations. Okay, well, let's get rid of this. Okay, here we go. We are going to do a surface crown run. So one thing that Faith Ann and I were talking about this week is the first tab that pops up when you're doing a surface crown run is actually some surface outputs. And we think we're actually going to move this to be the last tab so that you're kind of more focused on the outputs that make a little bit more sense. So this is just a little bit on this. If you select mid-flame wind speed as an output, you have to use a 20-foot wind when you're using the crown fire. And so that's behind the scenes, that has been done for you. It's an automatic selection. This is just really how we can make software work for you and instead of having so many things to remember. So I'm going to ignore this tab and we're going to go straight into fire behavior. You'll notice that the color changed. So now we're in this peach orange color. I am going to select rate of spread and flame length on this tab. And then in the fire type tab, I'm actually going to select most of these outputs. I'm going to ignore the surface fire line intensity because we are selecting the surface flame length instead. So one nice thing about the way that the guided workflow is set up, especially for students and intermittent users, is you can kind of see how things are linked a little bit better. So the two outputs that are linked to that transition to crown fire or the crown fire initiation model, you can clearly see these outputs right here. And then the two outputs that are linked to the active crown fire spread model are up here. So it just makes it a little bit easier, especially for teaching and those that aren't in Behave every day, which is most of you, to keep things straight. Okay, I am not going to select any outputs for size, but I am going to select both spotting models. So this is probably one of the biggest benefits of this, this new interface is you're not having to do this deep dive and remember or memorize where some of these outputs are hidden as they were in the Behave version 6 interface. So everything is a little bit more front and center and a lot easier to find. And so we have our outputs all selected. We're going to go ahead and say next. And now we are working on the inputs. I am going to use TU5, 165 is my fuel model. I'm just going to select one. You can say view, you don't have to. If you're only working with a single fuel model, it's obviously probably not necessary, but if you've selected more than one, you might want to click that view so you can make sure that you picked the right ones. Okay, fuel moisture, most often we tend to use the individual size class, and that is what I'm going to use today. I'm going to use a range for that 1 hour fuel moisture. So I'm going to do 10 to 5 in steps of -1. And doing that in reverse order just makes it a little bit easier to interpret the outputs. That is the only reason why you would do that. I'm going to select a single value for both my 10, 100, and live woody. So let's go with 7 for my 10-hour. So I'm kind of going like kind of middle of the road based on that range of 1-hour fuels. I'll use 8 for 100. And live woody, 80. So 60 is fully cured. So this is maybe what you might have about, a little bit past the prime of your fire season, generally when those woody fuels are on the decline. Could be in the spring too, when things are kind of ramping up towards green up. So on the wind and slope tab, you'll notice that right away, mid flame is grayed out, so it's not available, and 20 foot has been auto selected for you. We'll go ahead and do a range of wind speeds. So let's do 5 to 30 miles per hour in steps of 5. So I want to do a broad range. The reason is I want to show you guys all outputs, all fire type outputs in one run. For the wind adjustment factor, I'm going to use 0.3, which is often what we use for partially sheltered conditions. And in this case, I'm going to go ahead and say my wind and slope are aligned, and my slope is 40%. Okay, so the crown fire method, you'll notice right away that we have Finney rather than Rothermel in here. The main reason is just for consistency between Behave and the spatial systems. So in this case, I'm going to go ahead and select Finney, mostly because this was the crown fire method that made it very difficult to interpret your outputs in version 6. So that's the reason why I want to choose Finney today. So foliar moisture content, I'm just going to assume this is your average wildfire conditions. So normally we use 100% for our foliar moisture. Canopy fuel. Okay, so let's use 70 feet for our canopy height. And I'm going to run a single value for canopy base height. So I'm going to run 10. And canopy bulk density, this is one thing I want to point out. The units over here, this is the only variable that has metric units already selected. And the main reason is anyone that works in the spatial systems is very used to using kilograms per cubic meter. And our minds literally don't work in the English equivalent, which is pounds per cubic foot. But if you did want to change this, one tip, it's like human nature, I think you want to go to the arrow, but if you click in the white space, then that's actually how you can change your units. So you can change any of these units on the fly. And I'm going to use 0.15 kilograms per cubic meter. And I'll go next. Okay, so in this case, we have, in my mind, in this unit that you can't see, our downwind canopy cover is open. So there's actually a grass shrub is downwind. And so in this case, it doesn't have trees. It's open. So I'm going to go ahead and put 2 feet as my downwind canopy height. One other thing we noticed is these inputs for spotting don't really flow naturally. So be on the lookout for these to change in a future release. Number of torching trees. So, we often choose somewhere between 1 and 5 torching trees if you think about that group torching. So I'm going to go ahead and use 3. And in this case, the tree that I am most worried about spotting is going to be subalpine fir, and most of them are about 10 inches DBH. So I'll select my tree right there. Okay, that looks good. Now, the subalpine fir are shorter in stature than the rest of this mixed con stand. So they're about 40 feet. And in the topography inputs, so always think about your topography inputs as being in that direction that you would expect spotting to occur based on wind direction and topography. I'm going to use 1,000 feet for my ridge to valley elevation difference, mid-slope windward, and my horizontal distance is 1 mile. Okay, so I have all my inputs. Let it run. I'm going to go straight to the next screen to my output tables. Okay, so in this case, we have some surface, we have some torching, we have some crowning. Crown fire is all about thresholds. So between surface and torching, you have to cross a threshold for that crown fire initiation to occur. And then the next threshold is between torching and crowning. That is based on that crown fire spread. So let's take a look at these a little bit more. So the rate of spread is tied to the type of fire. So in this case, for surface, this is calculating a surface rate of spread. And then as soon as we round that corner and we have torching predicted, this is the rate of spread for torching fire. And same as we get down here into active crowning. And that holds true for the flame length. So probably the best analogy I can think of is if you think of working in any of the spatial systems, a lot of times we're using maybe 30-meter data if we're using native land fire data. And if you click in any one of those pixels, then this is exactly the information that would be presented from that pixel. Okay, I am going to scroll down to the critical surface flame length. So in this case, 6 feet is our critical surface flame length. And so if the flame length is predicted to be less than 6 feet, that puts you in surface fire territory. And if your flame length is above 6 feet, then you've crossed that threshold and you will have some type of crown fire. It could be torching, it could be active crown fire. So that is what the critical surface flame length output tells you. Now let me find my critical crown rate of spread. The critical crown rate of spread in this case is 60 chains per hour. And you'll notice that it doesn't change. It's not tied to the range for our 1 hour or our wind speed. So as soon as that rate of spread is predicted to be greater than 60 chains per hour, that's when you can expect active crown fire to occur. And if it's less than 60 chains per hour, then you'll have either torching or surface fire. The transition ratio is linked to that crown fire initiation. Will you have some type of crown fire, either torching or active? For these values that are really hovering right around 1, that's telling you shouldn't have a great deal of confidence in the outputs. It could go either way. 4 isn't necessarily like really high, but you can certainly be a lot more confident that you may have active crowning under this lowest 1 hour fuel moisture and this highest wind speed with a transition ratio of 4. And then I lost the active ratio. I'm sorry for the scroll. We have to move these outputs around so that they make a little bit more sense as you're working through the tables. The active ratio you can interpret in fairly similar to the transition ratio. So this is based on whether you will have active crown fire or not. So if these values are hovering right around 1, that's where you might be a little bit skeptical. But probably the the biggest value in how we have updated Surface Crown is if you're on a wildfire and you're thinking about talking to operations about what they can expect that day, I think it's a lot easier to find these thresholds and give them some advice, especially based on what you expect the fuel moisture to be. But in this case, I was thinking, of a huge variety of winds. So maybe your gusts are more in this 25 to 30 mile per hour range, and these lower wind speeds are um, just the static winds. So it's a lot easier to find these thresholds and give that information to the folks that need it. Okay, I am going to show you the spotting outputs, but we are not going to dwell on them. So spotting is a little broken right now, just in the outputs. So it's not showing me the tenths, which is really the output that we need when we think about spotting distance. So spotting distance from active crown fire, you will only see values if active crowning is predicted. And if active crowning is not predicted and you're in surface or torching, this is where you will see values for maximum spotting distance from torching trees populated. So I know Faith Ann was not able to save, so I'm going to go ahead and save. And look at this. I can save this anywhere I want. This is amazing. So maybe I'm just going to put it in I'll put it in my temp folder for right now. And it's going to give me this really long name that is not going to make any sense to you. So I might just say this is my surface crown demo run and save it. One thing I do want to let you guys know is if I come into surface crown again, you are able to run spotting for both torching trees and active crown fire on its own. So if these are the only two outputs that you want from the surface crown module, you can ignore the fire behavior piece and just run through it with these as your only two outputs. Maybe you could have active crown fire or torching on a wildfire, so you might want both of those outputs, or you can run them singly. So that option does exist. And I'm going to go ahead and get rid of my help and maximize my screen because I know that is important when you are working on a monitor or a laptop with a small monitor, which many of us have. Okay, we're going to do a surface contain run, and I'm going to set this up so you guys can kind of have an idea of what is on the horizon for surface and contain. So in this case, I'm going to select both rate of spread and flame length. And I don't want any of those outputs. And for my contain outputs, I'm just going to go ahead and select all of these. I think that's the easiest way, especially if you haven't run contain in a while. Just select all the outputs, and then it helps you figure out which ones make the most sense. Okay, so in this case, sorry, I'm going to move you guys so I can see my inputs that I already came up with. So we're going to think about a grass shrub fuel model for contain. And I'm going to use GS1 121. And individual size class. So a lot of times with contain, I usually suggest using that lowest 1 hour fuel moisture and like the highest wind speed. That's going to give you more of a worst case scenario. Think about what makes the most sense based on your objective. So if we think about the last run, we used 5% as our minimum 1 hour fuel moisture. I'm going to go ahead and use 5 here as well. And we used 80 for our live woody. So normally with live herbaceous, we run that just a little bit lower than woody. And if I click this button, we'll see the help again. We have updated, oh, let me find it. Good grief. We have updated this table. So if any of you have been involved in 390 or 490 in the last couple of years, you may have seen this. So the old table was really just for herbaceous fuels, and it was pretty old. It was published in the Rothermel 1983 publication, so been with us for a while. So Faith Ann and I worked through some guidance for both herbaceous and woody fuels. And then we ran this by a number of folks in different parts of the country because we really want to make sure we're trying to give good guidance for folks anywhere rather than kind of our West-centric fire courses have been in the past. So these are really inputs that you would use in modeling. And a lot of times, if you have sample data, they may be a little bit higher than how we typically run things in model land. Okay, I'll go ahead and get rid of that help again. And okay, we're good on inputs here. So let's go to our wind and slope. In this case, I'm just going to go ahead and use mid-flame. I could use either 20-foot or mid-flame. We typically don't have 10-meter data, so we'll just ignore that. I'm going to use 5 miles per hour for my mid-flame. And in this case, I'll run aligned. And my slope in this grass shrub area is 30%. Suppression. So typically, unless you know your fire behavior, we would typically select a rear attack because that is what we do in the real world. Line construction offset. So this is kind of fun. The line construction offset, you really have to know your fire behavior before you know if you need a line construction offset. So this is one piece of the puzzle that we haven't quite figured out. My best advice is to go ahead and run contain, look at your fire behavior, and depending on the resources that you would be using, that helps you determine if you need a line construction offset. So if you only have hand crews available and your flame length is predicted to be 6 feet, then you should definitely use a line construction offset. And typically 2 or 3 chains is probably adequate. They're just going to have to build a little bit more line to get around that. So this is really when you use a line construction offset, you are using a parallel attack. It's not an indirect attack. You're just moving off a little ways. For now, I'm going to go ahead and use 0. For elapsed time, a lot of times it's a little bit easier to think about elapsed time in minutes rather than hours. So what I noticed when I was putting this together, we left out a very important diagram. So we'll look at this right now. This really helps explain some of these inputs in contain. So you have say you have a spot. So that is your fire igniting, and then it starts spreading. This time between when that fire starts spreading and your resources actually notice that there's a spot fire, that is the elapsed time. And then once say you have some holders, once they call this in, that is called the fire report. And then you have this resource arrival time is the next thing to think about. So what you use for your resource arrival time kind of depends on the area. Are your resources on site? Do they need to hike to access? Just all of those things that you would have to think about. Okay, let's go back in here. So in this case, elapsed time, I'm going to run it pretty low. So 10 minutes, and then I'm going to go ahead and add a resource. So part of the problem in how contain has been set up previously is it's this iterations. You have to do all these iterations to find this complement of resources that can contain your fire. So I'm going to show you kind of how to end run this. And this is eventually how things um, will be. This option will be available to you in the future. So in this case, I'm just going to say, okay, my resources are on site and there's no access. They are right there. Resource line production rate. So this is where I'm going to run a range. And the range you use kind of depends on that rate of spread you would expect. Of course, I already know what to expect. So I am going to run a resource line production rate of 10 to 50 chains per hour. And I'm going to say, okay, I'm going to allow these resources to work for 4 hours. And in this case, I'm not going to add a resource. I'm going to go ahead and go to next. This will take a minute to run. Ooh, that was really fast. Contain is wide awake today. Go to my output tables. So setting it up this way, what I'm looking for in this contained status is I'm looking for where it goes from withdrawn to contained. So somewhere between 40 and 50 chains per hour for the production rate is where these resources that I have not named, they're just resources, can contain the fire. The other thing to check is my heading flame length. So it's hovering right around 4 feet. So you're kind of right on that border of being able to use hand crews. If you have equipment, you're golden. So at this point, I'm going to go back to my module selections, go to suppression. And if I rerun this from 40 to 50 in steps of 1, insert that new range, click my run button, then this is going to give me that actual line production rate. That's that target line production rate where I know I can contain the fire under these conditions. And then from there, I can kind of figure out that complement of resources that makes sense. Okay, so in this case, about 44 chains per hour, that's your target. And so once you have those 44 chains per hour, then you can start building out what set of resources you have available and can use to get you to that 44 chains per hour. Okay, there is surface contained. We are now ready for questions and answers.
Fantastic. Thank you both so much. There's so much work that has gone into this. There's so much information to absorb. If there are new questions, folks can feel free to add it in the Q&A section there. But I also wanted to see if there were any of the answered questions. If you guys wanted to go back and, you know, elaborate a little bit more on any of those answered ones.
So the first thing, Lynn, is we had a request for you to post the Crown run that you saved.
Oh yeah, you bet.
If we can do that. Chuck wants to break it, which is very helpful, so I don't mind.
Always helpful to have somebody willing to try and break things.
Yes.
So there is a question in the chat. Contain output results. Withdrawn means that the fire will not be contained by the resources on the scene. Could that nomenclature be changed to reflect that with a more direct term?
It's even more interesting than that. We brought in the code from WFIPS, and there's now like 8 different interpretations for what happens on an incident. So we're looking into all of them. Yeah, withdrawn means they ran out of time, and if they'd had more time, they could have caught it. But yeah, we can look at making these a little more user friendly because they definitely aren't. And any other suggestions like that, we really would love to have them. I have a question, Darcy. Can everyone see the answers to the questions in the chat? Or if they
They,
go to the Q&A?
yeah, they should be able to see answered questions.
Okay.
And if folks can't see all of the answered questions, please let us know in the chat and I'll make extra sure to gather those up somehow. But yeah, people should be able to see the answered questions.
So I just had a couple of that I wanted to bring up that have come up more than once, either here or here and other places. One of them was about the Portuguese fuel models. There are several publications related to those. We don't have everything in the help set up the way we want it right now. So we will be adding all of the fuel model parameters to the help system. Probably when we are able to bring in the custom fuel models, which is we're working on now. So want to make sure that that is there. But I did put links to two publications that will describe the method for the fuel models from Portugal. And the one, if it's anyone's interested in the ones that David Weiss did, that publication is no longer available anywhere on the web that I can find. But I can send you a copy if you just let me know. We will be posting links to a lot of the publications on the Behave website in the near future as we have time to update everything. So that's coming too. And the other one I wanted to answer was how to use the software once you get it on your computer. And once you download the jar file to your computer, there's no installation. I know that's really confusing to people. We've had several people call their IT people who called me to figure out how to install it. But all you have to do is double click on it. And if it's the first time you've double clicked, it will ask you what to open it with. And whatever version of Java you're allowed to use on your screen is the one that you should use. So you can also right click and select a program to run it with. Luann's going to demonstrate it since I can't run it on mine right now.
So you can put it anywhere. You could certainly put it on your desktop. I put it in Workspace, which is where I have a bunch of other software installed as well. So I can just double click on this jar, or I can say, okay, I want to open with, and in my case, I have both Java and this is Corretto. Corretto I have to download from the Forest Service Software Center. So that's why it has a really funny name. So, but before I opened it in Java, and I'll go ahead and open it in Corretto now, and you'll see it works exactly the same. Oh, I don't think it liked it because I already had one instance open with Java. So not playing today.
No. So the other thing I wanted to mention is now that we have a working version and the Forest Service has approved it, we need to fix a couple of bugs and then we're going to start work because we're going to put that out here in the next couple of weeks. But we'll be working with all of the DOI agencies on this. And I've also received a request for documentation related to from an IT person related to installing this on another machine from a city. So if you have any questions about getting it installed, you or your IT person can contact me. This is Faith Ann directly, and I can get you the information until it gets uploaded on our website, which will be very soon. So, but we will be working with DOI and CAL FIRE and a few other places to get it approved so that you guys don't have to fuss with that.
CAL FIRE is already working through the process of getting this on their approved software.
Awesome.
BLM should be easy. We worked with them on a test jar, and then we'll definitely work with the rest of the DOI bureaus. Any folks that are state, county, non-fed, if you run into any issues, like Faith Ann said, please just reach out. Um, Everyone has a slightly different process. And the only other thing I did want to mention is in the future, we are looking at repackaging that installation file so that you do not need to have these standalone instances of either Java or Corretto, but we are not quite there yet. Oh, I'm sorry. Okay, one more asked for how to open it. Sorry. I lost my share. Oh no, there's my share button. I'm sorry. Okay, there's a lot of buttons at the bottom of the screen.
Too many options.
Mm-hmm. Okay, so you can put this jar anywhere you want. I would just suggest putting it somewhere that makes sense. So for some of you, that may be your desktop, easy access, nothing to remember. In my case, I put it in here, and I'm going to go ahead and close this instance. So you'll notice we're on 7.0.1 now. I still have my 7.0.0 jar. I can double click it because I've already opened it. So it's not going to ask me how I want to open it. But the first time you do press that go button, it's going to ask you if you have both and Java and Corretto, it's going to ask you which one you would like to use. If you only have one of them loaded, I don't think you're going to get that same message. So yeah, you simply double click on it.
One of the other things that came up is the wind limit. Apparently, the wind limit has been removed from Flame Up Far Site. So we will look into removing that as well in an upcoming release of ours. We try to stay consistent with them. And so we'll keep working on that as soon as we find information. Usually it's the users that tell us something changed. So I appreciate you guys reaching out. I put our email addresses in an answer to one of the questions in the Q&A if you want to contact us in the future. And then one of the last ones is what do we call the fire type: surface, passive, active, surface, passive, torching, active, has all of that. We'll look into that again. We went with the simplification of using torching because that's what it tends to be called in the field, and we thought new users would be easier for them to adjust. We can certainly look at that again. I noticed that FlamMap now calls it passive/torching. So that's something we can also look for. And this is someone else today recommended that we color code the outputs for ground fire by ground fire type, and we are certainly going to look into that as well. We've had a request to show them how to open the file again. Did you do that? Did you see that question?
So was that the save file?
Yeah, that was Gary Jarvis. Yeah, and then
oh yeah, I can do that.
And then Shelly, it does not create a desktop icon. It is simply a file. It's just like a Word document or anything like that. You just put it on your desktop or anywhere on your computer and just run it. There's no installation, and you'd have to install it to create the icon. And we're looking into adding an icon to the file, the Behave7 files, but right now we haven't gotten that done yet. We keep going to the programmers with all kinds of ideas, and then we get a groan, and usually they then figure out how to do it. So.
Okay, so Behave6 users will remember that your outputs were not saved, but I just opened that surface crown run that we did first, and I can go straight to the results if I'm not looking to change any of the outputs or inputs, and my outputs are still there.
I think some folks are maybe still having a little bit of trouble getting that jar file to open properly. Um, I think maybe one thing to check is that you have Java or an equivalent, right, installed on your machine. And if it's not opening properly, that might be I know that that was the barrier that I ran into when I tried to open it the first time.
Yeah, let me share my
We're
screen.
still working on the installation instructions. Hopefully we can have that loaded by the end of the week. That will hopefully include some troubleshooting advice for folks.
Yeah, the latest troubleshooting that I've gotten was from Chuck McHugh, who is an excellent source for breaking software, which we deeply appreciate because that's a skill that not everyone has. And what he found was that you need to manually install Java, and I put the comment in the chat, which of course now I can't see. So let me see.
This is on a personal computer, by the way.
This is on a personal computer, yes. I'm not sure why I cannot get it to go on my computer. Okay, so what you're going to do is you're going to download and install the system, and where's the link? Java. Okay, so the one that people find a lot is this download Java for desktop, and that is not the one I want. So I'm trying to get into the chat, but of course, since I'm sharing my screen, I can't actually see what I want to see. There's the chat. Okay, let me go in here and see if I can figure out here it is. Nope. Sorry, the screen that says you're sharing is getting in the way of seeing the top of the browser window, so I can't see what I'm doing here. If you go to java.com/en/download/manual.jsp, which is why I put it in the chat, you'll see that there are 3 versions of Windows. And if you're on a personal computer, at least, if you can install the Windows, try installing the Windows offline 64-bit, that appears to have been the most helpful version for those who couldn't get it to run. So, and Chuck just put it back in the chat for everybody. So, but it's the 64-bit is the one that you want to get. But hopefully in the
Allison,
future,
there are
well,
multiple
Yeah.
times.
yeah.
Sorry
Well,
about
it's
that.
an interesting one, and that's okay. It's we are trying to get it fixed so that you guys don't have to do that too. So hopefully we'll be able to get that working, and then we'll go back and get that one approved through all of the agencies as well. So
We are trying to make installation easier.
yes,
And I think
because
this
right
is a
now
step
it's
in
not.
the right direction, but yeah, the old executable files are very problematic for agency folks. So this is our workaround, but I think once we repackage this, it will become even easier.
Mhm.
Thanks for that info, Chuck. I'll copy that for everyone.